Hello everyone, going to do a walkthrough on quiz 5. That was that quiz where we had a little bit of math in there. And remember, I'm really grading on process, not having the perfect answer, but of course, I think you want to know the perfect answer. All right, so let's start off with the first one. That is we're going to do the Seattle Radiology Group that plans to invest in a new CT scanner. The group right up here estimates. Now, you got to kind of take all these pieces in here to kind of build your logic out of what's going on here. So the group estimates that there's going to be $1,500 net revenue per scan. The primary market assessments indicate that demand will be less than 5,000 scans a year. Okay, so we got 5,000 scans a year. The group is considering a scanner, we'll just call it Scanner A, that would result in total fixed costs of $1 million. That would yield a profit of $500,000 at a volume of 5,000 scans. What is the implied variable cost per scan for Scanner A? Now, so this is kind of you got to kind of fill in the blanks here. So what do we know? We do know at the end of all of this, we have $500,000 of profit. Okay. So we kind of set up our basic profit equation, which would be, what are total revenues minus total expenses, and that's going to equal how much money we get at the end of all of this. So in this case, what is our total revenue? It's not listed, but we got to figure it out. So we do know that it's 5,000 scans and multiplied, let me put a little space in there. Multiplied, and we know that we are charging $1,500 a scan. So do a little bit of math here. And 15, hopefully this works out, times 5,000 scans a year. Okay, so that's going to equal, that's going to equal $7.5 million. 1, 2, 3, make sure I got all my zeros in there. Put my commas in there to help me out. Okay, yep, 7.5 million. All right, so that's how much money is going to be generated by the scans itself. So we're filling out our little problems here. So let's start off with that's how much initial revenue is generated. Remember, that's not profit, that's just revenue. Okay. And now we minus our expenses. So total expenses, as it's indicated in the chapter, is simply fixed plus variable. Add those together, and that's subtracted off of the total revenue. In this case, we only have one part of the puzzle, and that one part is we know the total fixed costs are $1 million. So I'm just going to plug that in. I know that I got $1 million. 1, 2, 3, and then 1, 2, 3. And then I'm going to be also minusing another figure off of that, and that would be the variable costs. I'll just put VC in there. Don't know what that is yet. That's the mystery here. But we do know what this all equals at the end. So the problem gives us the profit yield is $500,000. So we'll put that in. All right, so that's our formula. Basically, for those of you that are quick enough in your head, you could probably figure out what the VC number is. But I'm not, so I got to do it this way. So we got, let's go ahead and take off that $1 million of fixed costs, and that brings us to $6.5 million. Another little comma, minus our variable costs, and whoops, and we're still equaling 500,000. Okay, so now probably pretty easy to see what the VC number would be. I mean, you could subtract and do all that, but obviously VC, the variable cost is going to be $6 million. That's the only algebra. Yay, power, algebra. A little bit of basic algebra, not too bad. So we know that VC equals, equals 6 million. Boy, I really can't type this morning. So, but we're not quite done yet. So we want to know, when you look at, we want the variable cost, and right up here, variable cost per scan, and we're not quite there yet. So we got to know, just taking that $6 million and turning it into per scan. And I think we know how many scans a year, right? 5,000 scans a year, right up there. So we'll take that. And that equals, let me check out my math here. Equals our answer, which is 1,200, just did the math on my phone there, equals $1,200 variable cost per scan. So that is the correct answer for the first question in the quiz. All right, let's take a look at question 2. Somewhat similar, but a little different twist here. So we got a radiology group. They estimate $1,500 net revenue per scan. Sounds familiar. 5,000 scans are estimated in the market. The group is considering scanner, we'll call it scanner B. They have total fixed costs at $800,000 and would yield a profit of $450,000 on 5,000 scans. What is the estimated break even? So we got a break even question here, a little bit different. All right, so the first thing we want to do, we want to set up our basic kind of profit equation. And what we need to know is what's total revenue. And that's simply, we know how much we're charging per scan. So that's 1,500. And times, we're saying 5,000 scans. And if we do the math on that, that should equal, let me double check myself here as I pull up my phone, and 15 times 5, you can follow along with me if you like. All right, so that's 7.5 million. All right, so we got that part. That looks good. Now let's go ahead and set up our profit equation. So we got the 7.5 million minus our fixed costs, which we are given that, which is right up here, that 800,000, minus, we got a mystery, minus our variable costs. We don't know what that is yet, so we'll just call it VC. So we got to figure that one out, which you kind of built on from that first question. We do know what the total is at the end of this whole thing. It'll be $450K in profit. Okay, so let's figure out what that VC number is. Most of you can probably do that in your head, but I can't. So let's collapse those two numbers together. Let's take off that 800,000. That's going to get you 6.7 million. And minus, still our mystery number, minus our variable cost. Don't know what that total number is yet. Whoops. And that's still going to equal 450,000. And I think from here you can figure out, just do a little basic algebra, and you can figure out that now VC, or variable cost, total variable costs, are going to equal, checking my calculator here, yes, 600 or 6,250,000. All right, so we know that. Total variable costs. We need to know variable cost per scan. Pretty easy. Let's just throw a division in there. We know we've got 5,000 scans in this thing, so we're going to divide by 5,000 scans. And that equals, running some math here, checking my numbers. Yep, looks good. That's going to equal $1,250 of variable cost per scan. We're not quite done yet. We still have to, we are doing break even. So now we need to take some of that information we got and put it into our break even formula, which is that total revenue minus total variable costs minus fixed cost equals profit. Again, kind of our profit formula. But in this case, break even is, what is break even? Break even is zero profit. I've covered both my fixed and variable costs. So that's the key there. Break even is that zero profit point. When does that happen? So let's go ahead and set this up. And it's a mystery because we don't know how many number of scans. Remember, we're looking for number of scans that we want to get to that zero profit area. So let's set up our formula. Now this part here, this is going to be the total revenue area. So we know we're charging $1,500 to get those kind of that net revenue for those scans. So I know that number, so I'm going to put that in here. But it's going to be multiplied times a number of scans. I don't know what that is. We'll call it X. Okay. And I'll put a parentheses on there to make it look, I guess, correct algebraically. Now we're going to subtract off of there a variable cost. Okay. Well, we've calculated our various variable cost per scan, and we do know that is $1,250 times X number of scans. Again, we don't know the number of those scans yet. And the easy part is we do know how much in our fixed costs that we have. That's 800,000 or 800K, like we like to say. So 800,000. And this is where a lot of people kind of mess up. Zero. We want zero. How do we get to zero from this point? Okay, so let's move on. I'm going to scroll down here to the next page. All right, so we've got that set up. So let's go ahead and move some things around algebraically. I'm going to take that 800,000. If you remember, if you add, things to both sides of the equation, you can move things around too. Even if you're not good with algebra, I think intuitively you can kind of figure this out too. So let's just go ahead and move that 800,000 over, leaving everything else the same. Okay, so we got that. That's our total revenues, and minus our variable costs. Again, still the unknown is X equals 800,000. Because if you think about it, this minus whatever this is, has to equal zero. So let's move that 800 over to the other side. Now what we're going to do here is we're going to combine. Let's go ahead and combine these numbers, which you can do. Again, a little bit of algebra here. Worst case scenario, you could just start plugging in numbers and trying to figure it out if you forgot kind of some basic algebra. But let's go ahead and kind of do, I guess, correct. So you take the 1,500 x minus the 250x, or 1,250x, and that will give you 250x equals, and we haven't messed with the 800,000 that we put over there. And now all we got to do is divide the 850, or or the 8,000 to figure out what it takes to get to the multiplied side of it. So 800,000 divided by 250 equals, let's see, check my math here. Yep, equals $3,200. So with that, let's see what we're looking for here. Or I'm sorry, not dollars. Whoops. So, misspoke there. Number of scans. So we know that it takes 3,200 scans for our revenue, that profit equation, to equal 0. So that is the break even. You got to have 3,200 scans a year. After that, you're starting to make money. So that is the correct answer for number 2. Okay, moving on to number 3, question number 3 in the quiz. This one's going to use information that you have used in questions 1 and 2. So hopefully you guys saw that and are able to pull upon that information. I remember, even if you didn't get the correct answer, as long as I saw a process in there, points are going to be awarded. But let's go through the correct answer. So what you want to look for here, well, let's kind of go over the scenario, I guess, is the group. Again, we're looking at a radiology group. They want a CT scanner. The group estimates that you're going to get $1,500 net revenue a scan. Sounds familiar. Demand indicates that there'll be less than 50,000 scans a year, or 5,000 scans a year, I should say. So we got that in there, all very familiar. And now we have the choice between 2 different types of scanners. Each scanner has a capacity of 5,000 scans per year, but involves a different mix of labor and capital. So our variable costs and our fixed costs are going to be different. So scanner A, very familiar again, total fixed costs here are going to be $1 million and would yield 500,000 in profit at 5,000 scans. Scanner B would result in total fixed costs of 800,000 per year and would yield a profit of 450K, 450,000 at the same 5,000 scans. Now, here is the trick. What we're asking for is, what are the number of scans that both scanners are equally profitable? So what you're basically setting up is, that revenue equation of, that your or total profit equation. You got your revenue minus your fixed expenses minus your variable expenses. These 2 scanners are going to be equal. So you're basically setting those 2 formulas equal to each other, and you're cranking through a little bit of algebra. But you got to find some information before you can set that up. So the big thing that you're looking for in setting that up is you need to know your variable costs, which in this scenario doesn't give you the variable costs. You have to figure that out. Luckily, in the previous 2, you already calculated that variable cost per scan at some point in the calculation. So let me go back up to back up to 1, I guess. We'll look at number 1. Remember, we calculated the variable cost at $1,200 because they're the same numbers, exactly the same. So you don't need to repeat the work there. And so you got $1,200 there. And then for the other one, we had to get variable cost and then take it a step further in number of scans. But in this case, as we progress through the equation, we still calculated that variable cost in there at $1,250. So remember that. So I'll skip the steps there on calculating the variable cost per scan because we've already done it. What we need to do now is to set up the formula, which is really the trick of the equation. That's kind of the hard part. So the way I approached it is that we have our standard 1,500 scans at, or $1,500, I should say. I probably should put a dollar amount on there so you guys know. Remember, we're making $1,500 per scan, says it right there. Okay, times X, number of scans. We don't know what that magic number is. We got to figure out at what point x is equal on both sides of this equation. I'll just at random, I guess we'll put scanner A on this side, and we'll put scanner B on the other side. So this is scanner A. And then we're going to do at minus our variable costs, which were we calculated at 1,200 per scan. And our fixed cost for that scanner A was, I'm just going to abbreviate this, guys, so I don't have to do all those zeros, 1 million. Okay, now that is going to equal the profit formula for that scanner B. Again, we've got $1,500 we're making per scan. I don't know how many scans we're doing. Minus the variable cost, which was on scanner B, which is the same number here. Just double checking. Okay, that's right there. It's $1,250. Okay, so we're going to do 1,250. Again, same number of scans. I don't know. Minus the fixed cost for this particular scanner, and that was 800 right there. Again, if you go back to question 2, so you can see it's exactly identical. 800 right there, so you don't have to worry about that. So I'm going to put that in there. I'm just going to put, we abbreviate 1,000 as K. So if you ever hear me say 800K, it's 800,000. All right, so we've got that. So now we've got to basically just do some, some reduction here on both sides of the equation. So we can go ahead and, I guess, take those x's right here. We can collapse those together. And 15 minus 12 is going to be 300x. Again, we still don't know what x is. Minus the 1 million. We still don't know, again, number of scans. Don't know that. Oops. And let's do some collapsing on this side of the equation as well. That's going to be 250x minus our fixed costs, which we said were 800K. Okay, so we've got that. That looks good. All right, now let's just continue to kind of crunch through a little bit of algebra. What I need to do is I need to isolate x to one side of the equation so I can solve it. So the easiest thing I'm going to do here is I'm going to take that 250. I'm going to subtract 250x from each side of the equation to get rid of, again, in order to solve for x, I got to have on one side. Hopefully you guys remember that from old algebra days. So we're going to get 50x after you combine them together. I'm going to subtract, again, 250 from both sides. It's going to completely wipe out this x here, and it's going to wipe out all but 50x right here. That's actually in dollars, if you guys remember. So 50x, I'll put that there. And I still got my minus 1 million. Those are those fixed costs. Okay, equals. Okay, we got rid of that. Got rid of the x on that side of the equation, but we have this weird negative number, 800,000 in fixed costs. So again, going back to a little bit of fundamental math, if I want to get rid of that negative $800,000, remember that's not a numeric, that's not an algebra. That is a K for meaning 1,000. I have to add 800,000. So let me add. I can add 800,000 to each side of the equation, which well, let's go ahead and do that. And I think you can probably run that in your head pretty quickly. So I got 50x minus 200. I'll actually go ahead and write it out here for you guys. $200,000 dollars. Okay, now equals 0. Can't solve for 0. So what you have to do, you got to move something over to that side. Easily enough, I've got 200,000 sitting there, so I'm going to take 50x. Again, I'm going to add 200,000 to each side, so that negative 200,000 goes away, and I am left with 50x equals, and those are really dollars, if we remember from up in the beginning when we started all this, equals $200,000. So now I just need to solve for x. Division. If you run that division, x equals, let me double check my math here. X equals, yep, looks like it's checks. X is going to equal 4,000 scans. So at what point are the scanners both equal? At 400,000. You got those running in your facility. At that point, when you've reached 400,000 scans at that point, or 4,000 scans at that point in the year, they have been both equally profitable. It's interesting, but does that profit hold up beyond the 400 or that 400 or 4,000, I should say, 4,000 scans? How do those scans, just as a theoretical question, that would be kind of the next choice. Which scanner would do better for you in the long run, higher volume areas? So, but we're not asking for that here. All we wanted to know at what point they were equal. So there you go. The answer for number 3 is 4,000 scans. All right, let's take a look at question that's actually number 4, question number 4. We just did question number 3. Let me fix that little typo right there. Question number 4. And we could take a little mental break because this one is pretty easy. Hopefully you didn't spend too much time on this one. So right now we just want to know, what is the contribution margin? And you can grab this right from your textbook, but it's basically that revenue per unit minus the variable costs per that unit, patient, scan, whatever you've got, equals your contribution margin. And luckily, they give you a little bit of a trick in here. They throw some fixed costs in here, thinking that you may have to calculate something else. But luckily, they give you all the information right there in front of you. So you've got your revenue per inpatient day. So we got that already. That's 1,200. So again, that's our revenue per unit. In this case, we're using inpatient days. So we're just going to put the 1,200 minus variable costs for the whatever in patient days. So do we have it? Boom, they gave it to us. Easy. Oh, wow. Is this one that easy? And yes, it is. It's just that easy. So you just do the simple subtraction there, and you come up with You come up with $800. So the correct answer for number 4 is $800. And just to add on to that, remember contribution margin. What does that mean? It's the contribution, think of it, the contribution made towards covering the fixed costs. So even though we've got $10 million in fixed costs up here, each time we do one of these inpatient days, we're knocking out 800 will be used to contribute towards covering that fixed cost. So I guess think of it that way. It's a contribution to what? It's a contribution to covering the fixed costs. Of course, fixed costs not included in this calculation because we just want to know the variable component of what we're doing and how it's going to impact the overall fixed costs of our operation. So there you go. Question number 4. Hopefully that one was easy. Okay, now on to our very last one. Hopefully, again, this should be, if you got past question 3, you're kind of the hero. So questions 4 and 5 hopefully are a little bit easier. So with 5, we got the following information on Palm Bay Hospital. We've got our fixed costs, our variable costs. We're using inpatient days, so kind of familiar with the previous question, and our patient revenue per day is at 1,200. So what is the break-even volume in patient days So another break-even analysis. The first thing we want to do is we want to set up our kind of that profit break-even equation, or I call it the profit equation. But we take the per unit, that per unit revenue that we're making. Again, that's given to us. That's 1,200, and we don't know the number of days, so we're going to leave that as an X. And then we're going to be subtracting some stuff off, right, guys? So what are we going to be taking off? We're going to be taking off, obviously, those variable costs, and that's given to us in the formula or in the question. So it's another $400. Okay. And we don't know how many inpatient days, but we do have some fixed costs to take care of, and that is $10 million. So we got $10 million. If I can get all my zeros in here. All right, and this is going to equal, I like setting it up to 0. A lot of you could probably jump ahead and just, you already probably set it up to cover the fixed cost. That's great if you want to do that. Totally up to you. But so now I'm going to move that $10 million to the other side so I can solve the equation. And I'm just going to leave the dollar signs off because I'm a terrible typer. All right, so we got then the 400. Still don't know what X is. Again, we're going to add 10 million to each side of the equation. That deletes the 10 million on that side and now puts it on this side. And you can see here, we'll do some more reduction in here. Bringing those two figures, the 1200X and the 400X together, we're now going to get $800 times whatever number of patient days is going to equal 10 million, 10M. And just do your division. And if you do your division into that, X will equal, double check my math here. Yep, 12,500 patient days. So that's what you need. The break even in days for Palm Bay Hospital is 12,500 patient days. Of course, there's not that many days in the year, but when you have multiple patients, 300 bed hospital, whatever. This is probably 300 bed hospital, but so that's the correct answer here is 12,500 patient days. Now, just to double, as a kind of a chiming in here real quick, a last little note that I want to add on to this. Hopefully you've watched this video. There will be these equations will be on the final, or these questions will be on the final. They will be very, very similar. I will change a few numbers. So do take some time to run through these samples. So that way you can do really, really well on the final exam. So there you go. Just thought I'd throw that in there for you. Thanks.